Welcome everybody to the Daily Space Weather Show. And first things first, thanks to our new subscribers on the channel. So it's exciting times for space weather as we've got geomagnetic storm conditions to continue for the next about 24 hours. Another CME on the way, new sunspots forming, and lots more to talk about here at the Smash News Network. Least busted name in news. This is September 2nd through September 3rd to date from the SDO ionized helium frequency. We did have an M6 class flare also happening just this morning, largest flare in quite some time. You'll see it happening there up in the northwestern limb. You may also see a filamentary reorientation that may have been associated with a coronal mass ejection. Another one headed toward Earth. We'll tell you all about it. First, some composite imagery for the same time frame that does show a great view of that filamentary reorientation. It looks like most of that plasma splashed back down, but there's a second event sort of happening at the same time from over here. So yeah, I believe there is a second CME headed toward Earth. We can expect that to arrive sometime early to midday on September 6th. Next, sunspots. And we've got two new sunspot groups that just formed in the eastern limb. One's up here higher in the north. One's down here in the south. This one up here in the northwest has already got a name. We'll talk more about that in a moment. First, the colorized magnetogram. These videos are all SDO browse data. September 2nd and September 3rd to date. Let's take a brief look at what's going on planet Earth here. Which volcanoes are erupting, you ask? Well, so do I. They include Abico, now producing a 12,000-foot plume of volcanic ash. It's a flight level 120, flight level unknown over Mount Mayan on Luzon Island, Philippines. 6,000-foot ash plume over Luatolo. Popocatépetl continues to produce a 30,000-foot ash plume there over central Mexico, flight level 300. It's an uptick for Popocatépetl. Heading down to Colombia, we've got Nevado de Ruiz exploding, flight level 240. Flight level 220 over Sangay in Ecuador, Revenador in Ecuador, flight level 140. Continuous ash emissions from Sabancaya in Peru. Excuse me. DAG. And last but not least, Villarrica. Let's see. Villarrica here. What do we got? New ash emissions from the summit yesterday. No indication on how tall they've gotten. Let's see what's happening seismically. And it has been very calm in the past 24 hours as far as earthquakes. So only one 5+ magnitude quake in the past 24 hours. It was a 5.3 at Peru, and that was at depth of 149 kilometers. So no other quakes of a 5 or greater magnitude. So coronal mass ejections and coronal hole high-speed streams striking Earth. That is the real story to cover. So let's get back to space. Here's some more imagery for you. Here is the SDO featuring 171 angstroms ionized iron. And check this out. The 10.7 centimeter radio flux, now at the lowest levels that we've seen since the end of April 2023. So the radio flux now all the way down to 131 solar flux units. Don't expect this temporary lull in activity to continue, as we still have yet to see solar maximum. We're probably well over a year until solar maximum. So don't expect things to continue to dip here. The length of a solar cycle is quite uniform over hundreds of years. Space Weather Enthusiast Dashboard, and we're also predicting Space Weather Enthusiast Dashboard, that's NOAA's prediction. We're expecting geomagnetic unrest and storm conditions to continue through mid-morning tomorrow. So by about noontime tomorrow, you can expect the geomagnetic storm, geomagnetic unrest conditions to cease. There is coronal hole high-speed stream as well as coronal mass ejection activity sort of happening at the same time here. So here's Earth's magnetic moment from space for the past 4 hours. It's our geospace magnetosphere movie. And lots of high-density pressure around the planet at the moment. That's what you can expect when you've got coronal mass ejections and high-speed streams showing up at the same time. It is a high-pressure environment. The units depicted here are nanopascals, which are magnetohydrodynamic pressure. So quite a bit of plasma hanging out. And there have been quite a bit of aurora seen last night. So we'll show the North American geospace ground magnetic perturbations map. That is Earth's magnetic moment from the ground for the past 4 hours. If you've got auroral imagery, hit us up on Discord. There's a permanent invite link to our Discord channel at smashomash.com. So here's the global view. And we don't care if you're getting imagery of the aurora australis or aurora borealis. Share those images with us. You can also hit us up on Twitter or Instagram. But the best way is to join the Discord channel. Again, you can find a permanent invite link to that at smashomash.com right on our home page, as we've built a massive web ring to benefit people like you. So there are the past 4 hours of Earth's magnetic moment from the ground, and it looks like there are significant substorms there, so possible aurora being able to be seen quite far south in the past 4 hours, which is what's depicted on that video. Another great way to figure out where the aurora might be seen is by looking at induction into the power grid. This is our geoelectric field map, so you can check that out. That's also available at the Space Weather Prediction Center. The geoelectric field map, US and Canada. And things are subsiding now, actually, at the moment. So keep in mind, folks, there is a second CME about to strike. So there were actually 2 events, and we've only seen one so far as I can tell. KP index currently still in geomagnetic storm conditions. KP 4.67 is the current situation. The highest we've seen is KP 5.67. So we may actually see a stronger strike. Keep in mind, folks, after CME impacts, there's often less resistance in between Earth and Sun, as plasma is sort of swept away by the initial CME. So the second CME impact could actually be a stronger impact. Expecting that sometime in the next, technically in the next few hours. So again, we can see this now subsiding. Also, this top line here is very important. That red line is the vertical component of the magnetic field, measured at Lagrangian point 1. And you can see that has just moved into positive territory. So expecting until that new CME arrives, that second CME, expecting geomagnetic unrest conditions to wane here. So we're seeing a dip in the solar wind speed. We have seen a dip in the solar wind density over the past 5 or 6 hours. And now we're seeing the magnetic field orientation switch to positive BZ. So we'll have a northward magnetic field here, and that will tend to induce less current into the earthly system. Current conditions are about 10.5 protons per cubic centimeter for the solar wind density. Solar wind velocity here, 468 kilometers per second. We did see the density make it all the way up to about 30 protons per cubic centimeter here. Just over 30 there. And that was around the peak time, although we didn't really have a very strong negative BZ at that time. So there were some fleeting moments there with a fairly strong BZ, negative BZ that is. So that's what's going on for solar wind. And here are our GOES magnetometers, which are showing some pretty rapid variations there, no real surprise. The GOES 16 and GOES 18 are geosynchronous near equatorial satellites. And that is what you could expect to see with a mild geomagnetic storm, which is what we've seen so far. Next, our top view ecliptic plane field plot. As forecast yesterday, Earth is still in a North Pole current sheet. So if we bring up the latest image, So we've got a sector boundary crossing coming, where Earth will leave the North Pole current sheet and enter this South Pole current sheet. Still got a ways to go there. Could be as many as 12 hours. It does somewhat depend on the evolution of those new sunspots in the eastern limb, so no real forecast there. But there is a sector boundary crossing coming probably within the next 24 hours. Here's our line of sight field plot. Which brings us to coronal holes. Yes, holes in the sun's atmosphere. They tell us about the solar polar field reversal process. At the moment, we've got all North Pole-oriented coronal holes here, except, well, okay, I stand corrected. There are some South Pole-oriented coronal holes just rising up here over the southeastern limb. Let's take a look at those from SDO. Here is the 211 angstroms wavelength. The optimal wavelength to show coronal holes. So again, those are all North Pole, except right down there in the southeastern limb. Right down here, there's one just rising. That is South Pole orientation. The first harbinger of that South Pole current sheet. Huge filament here rising over the northeastern limb as well. Next, sunspots. So here's what's going on. And again, we've got two new groups about to get names in the eastern limb. So this one will be 3420, and this one will be 3421 if they stay intact long enough. Let's take a closer look at those from the SDO. There is SDO Continuum, September 2nd through September 3rd to date. So you'll see a sunspot rapidly form down here, right here by my pointer. And then another one forming right up here. Pretty quickly as well. They both look like beta gamma class sunspot groups. So those are the places to keep an eye on. Now when I say eye on, well, pardon the pun. Next, it's time to move to energetic particles and solar flares. And indeed, that most recent M6 class flare did not produce any relativistic particle events, not yet, despite being a long-duration flare. It is somewhat behind the limb. So, goes proton flux here, returning back to baseline levels following a mild proton event there on September 1st. And here is that largest flare of the past, well, quite some time, actually. An M6 class flare, peak flux was around 8:30 universal time this morning on September 3rd. Let's take a look at flares from SDO. There's 94 angstroms, one of the optimal wavelengths to view flares. And I think we can zoom in a little bit closer here. And here's 131 angstroms. Next, we've got to keep this thing moving because it's time to step back and take a look up, as a lot of people have been taking a look up. Again, if you've got imagery of the aurorae or anything like that, drop us a line. Here is your star chart. This is what's going on over Lehigh Valley, Pennsylvania. You've got a large bright moon up there just ahead of Jupiter on the ecliptic. Also, the third brightest object visible in the morning sky is Earth's sister planet there. So that's what's going on at the moment over Lehigh Valley, Pennsylvania. It's our star chart from skyandtelescope.org. You can make your own, put in your zip code, press the Now button, and you'll have a view for your latitude and longitude at your time. Next, the solar system forecast. Here's where things are today. And let's move this forward 1 week. Here's where things will be on the 10th of September. How time flies. Speaking of flies, check it out. This comet from, well, it originally appeared in 2006, I think. Actually, in 1995. However, in 2006, it broke up into dozens of fragments. That comet is known as Comet Schwarzmann-Wachmann. And that is from the Hubble Space Telescope. That's the astronomy photo of the day at apod.nasa.gov. Next, coronagraphs. And again, I believe there's a second, well, really a third CME headed this way. It started to appear in the coronagraph imagery around 1900 Universal Time yesterday. So you should see it on here. Wait for it. And right in there. It looks like it's mostly going to miss Earth to the northeast, but I do believe there is going to be an earthly directed component in that. So again, we can expect that one to arrive sometime early to midday on September 6th. So another coronal mass ejection headed this way. Again, exciting stuff for space weather. It's a great time to have found our channel, wouldn't you say? Here are today's coronagraphs. Those were yesterday's. Here is an additional 43 frames from today. And multiple additional events happening here. We don't think those are earthly directed CMEs. Anyway, let's view some more imagery here. But first, don't forget to press like. If you're new to the channel, congratulations on realizing it exists. We remain frankly surprised with the state of censorship on the internet nowadays. It's criminal, it's evil, it's disgusting, it's ridiculous, and it's frankly anti-human and anti-American. So, anyway, press like. Again, congratulations on realizing the channel exists. Press subscribe, get involved, visit our links, and increase the probability that these videos will continue to exist, remain publicly visible, and free for all to view. You can find our links on the homepage, as well as in the description below this video. Here come some more coronagraphs. Here's LASCO C2 and C3. And let's just pause these. This is the one that I expect to have an earthly directed component. There are multiple filamentary releases there happening sort of around the same time. Again, some of that ejecta, I believe, is on the way to Earth. So we've got some better imagery for you here as well. Here we've blown those up. And let's bring that back. Here's the full run. Please note those aren't perfectly synced there. The time and date stamps are on the bottom left. So here comes the next CME there, popping off at about 1830. You can see it coming out of the coronagraph. That is from plasma release events that were on the Earth side of the sun. So that's what's going on. Another CME to arrive, likely on September 6th. We'll also show stereo A. We do have some limited data from there. And great imagery there of this morning's CME off to the west. That's not likely to strike Earth. Difference imagery on the right, raw coronagraph on the left. Yowzers. A great example of how you can have lots of space weather popping off when the sun's activity overall, at least on the Earth side, is dropping down. Next we'll move to filaments. And Lermonth, Australia's ground-based hydrogen alpha telescope is showing a lot of filaments. So check it out. We've got one here, 2, 3, 4, 5, 6, 7, 8, 9. Crown prominence, filaments, filaments, filaments. Over a dozen on the Earth-facing portion of the solar disk. And any one of those could turn into a coronal mass ejection. So again, exciting stuff for space weather. It's a delight. Emanating from our source of light and life. We also show the grayscale imagery as it's good at showing prominences, and there is a huge prominence here, a very dense one, rising up over the northeastern limb. Likely behind that is another sunspot group. By the way, if you want to name filaments after living people, join us over on Twitter. You'll also see our auroral shares, and we're not going to show them on the channel because we want people to follow us on Twitter. It features all sorts of information besides what we're normally talking about. So hit us up over there, and if you think Elon has solved the problem of censorship on the internet, you are living in a delusion. Elon has not fixed censorship. Elon has stated that he has left the censorship in place. So he exposed the censorship. However, he has not eliminated it. Deboosting features continue on Twitter, which I refuse to call X. I'm not calling a company a letter. It's just ridiculous. And you can see that CME popping off there in the northwest. So another one happening there as we create the video. It's too early to see that on the Coronagraphs. That sunspot has certainly, that's 3413, I think, and that certainly has been the source of much excitement, including the location where CMEs emanated, from which we're seeing aurora on planet Earth right now. That's the last couple of hours from the GO 16 SUVI. And let's blast through our bonus features. First bonus feature is satellite charging hazards, and we have some significant ones here in the Western Atlantic, the Caribbean, the Gulf of Mexico, Central America, Mexico, and the Eastern Pacific. Those are low-energy electrons building up on the outsides of spacecraft. You can expect some minor communications errors as a result of that. The GO's electron flux here in a sort of an operating range. It has come up off the floor, despite significant space weather arriving at Earth. Here's the one-year graph to put it in context. Again, coming up off the floor here, we're just in a moderate to low level of electron flux. And NOAA's forecast is one with which I would agree. Those green boxes are the forecast, the yellow diamonds are the observation. That is the relativistic electrons of greater than or equal to 2 mega electron volts, which is measured at the F layer of the ionosphere. That's located at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with the information depicted. Here is the ionosphere, and there are a lot of low-frequency anomalies as forecast. So that is the raw vibrational frequency there in megahertz. Millions of vibrations per second at the bridge between Earth and space. Again, the F layer is at about 300 kilometers of altitude. And we'll also show the anomalygram just in case that's all Greek to you. So as forecast, lots of red showing up here on the map. You'll also see the largest variations happening right in here. That is the South Atlantic anomaly, which is kind of right over the center of the South American continent. So as always, you're going to see the most rapid swings from high to low frequency anomaly in that region. But as you can see there, especially at the end, you'll see lots of red showing up, lots of low frequency anomalies as the ionosphere gets scintillated by incoming space weather. Anyway, here's the latest image, 10:30 universal time for the ionogram and 10:30 universal time anomalygram, lots of red. We also show total electron content. That's free electrons to about 12,500 miles of altitude. Feel free to pause the video on this frame if you're not familiar with distances to those things in miles. Here are the free electrons from your GPS satellite down to your handset, and looking quite organized here. Not looking like a pole flip, not looking like a scary, spooky geomagnetic excursion. Looking quite normal indeed. Most of those GPS errors are most likely around the equator at noontime. And I've said it before, I'll say it again. We see more organized total electron contents when we see high electron flux. So there's the facts. Those are the most likely places for GPS errors. That's literally a count, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. We'll also show total electron content over North America. This is the anomaly from the 10-day average. We are seeing some small high electron content signals there. There are some over the Baja California and the East Pacific. High electron count anomalies shown in red, low electron count anomalies in blue, and last but not least, the latest intensitygram and the latest magnetogram. So here are these new sunspots. There's that little pore up there. It is beta gamma class. I see 2 ombre. This one down here, a little bit bigger ombre, also beta gamma class. Anyway, there's your full disk rockback. And let's move to meteorology. Now, we haven't looked at Saharan dust for a while, so let's start with that. On our meteorology segment, we throw it in as a value-added service. I realized over 20 years ago it's way too easy to forecast the weather, especially with all the data at our fingertips. So that's depicting Saharan dust and surface winds over the North Atlantic. And yeah, there are still 3 lows there, and of course, they're in the formation of a triangle. And everybody knows triangles are very scary. Why? Because the Illuminati or something. So look at, oh my God, it must be a pyramid with an all-seeing eye on top. Those are where the HARP bases are located. Pardon my sarcasm. Mankind is not in control of the weather. If you think mankind is in control of the weather, you don't understand HARP or aircraft tech or atmospheric physics. Anyway, that's what's going on as far as Saharan dust. It's pretty dusty. And some of this dust making it all the way up into the extreme North Atlantic there. It's chasing those low pressure systems and weakening them. Sorry for all you hurricane hopefuls. And let's show what we normally show. Here are the surface winds of the eastern world. Here are the jet streams. Upper level low here hanging out in the West Pacific. Here are the jet streams of the central world. Shout out to Remco Evenepoel for a great chase yesterday in the Vuelta a España. Especially shout out to Sepp Kuss. Yes, Sepp Kuss. Congratulations on taking the general classification jersey. Sepp Kuss, the American rider from Durango, Colorado, now in the lead overall at the Vuelta a España, the 3rd biggest bike race in the world. Here are the surface winds of the central world. Surface winds of the west. And let's don't forget the west's jet streams. The jet streams, they largely control the weather, not humans. Next, we're going to show the ozone layer because it's one of the great features of windy.com. There's a free mobile app you can download, by the way, windy.com. And I just want to show the big variations in the ozone layer here. So the ozone layer here, much thicker down there in the Southern Ocean, much thicker than over Antarctica, where there are twice as many density units there. There are 423 density units right there, and then right over here, only 197. So it's like half as dense in those areas. If you want to watch the ozone layer, and if you're very spooked of holes in the ozone layer, well, there you go. Oh my God, look at those spooky ozone layer holes. Oh my God, it's only 167. Oh dear God, what are we going to do? Here's what we're going to do. We're going to show clouds and fog over the western world using shortwave radiation, which shows clouds and fog at nighttime. Massive number of low clouds there over the southeastern Pacific. Look at all those low clouds. Crazy number of low clouds. Also lots of low clouds over the western Atlantic there, trailing behind the remnants of Hurricane Idalia. Next, your weather.gov map showing significant flooding here for Wyoming, Idaho, Oregon, Nevada, and Utah. We'll scroll down to show you the key at weather.gov. If your location is lit, click your location on weather.gov and get your weather warnings. Those are too many counties for us to cover in this perfunctory weather video. However, we will show you forecasts for the lower 48. Here is total accumulated precipitation based on the GFS 72-hour model. Here is pressure and precipitation for the same model and same time frame. Next, the jet stream, which does control the weather, unlike mankind, who is incapable of controlling the weather. That is the 250 millibar forecast, which is effectively the jet stream based on the GFS model for the next 72 hours. Last but not least, there's a heat wave, which is spreading to the mid-Atlantic states. 72-hour GFS temperature anomaly forecast in degrees Celsius, and we're expecting temperatures at like over 12 degrees Celsius above normal here for the coming week. Temperatures expected in the 90s here in eastern Pennsylvania. So those are the forecasts. Here's our lightning mapper. Some heavy lightning there over Central America, southern Mexico. And you can see some of those satellite failures happening up here. Some non-directed energy weapons there. Check it out. Oh, check it out. Oh my God, look at that, folks. It's a directed energy weapon. It's a laser beam from space. It's electrons building up on the outside of satellites. Next, a real-time lightning map, courtesy of lightningmaps.org. And we do have some terrestrial strikes here. Looks like some minor lightning there in Nevada. I use it when I hear thunder. I don't know about you. Today's featured product on the Amazon shop is bulk spices. Yeah, bulk spices. Are you buying little tiny jars of spices that cost $8? Well, here's a 1 pound jar of turmeric that only costs $10.33. Don't be buying little tiny jars of spices at the grocery store. Buy bulk spices through our Amazon shop at amazon.com/shop/smashomash. Links below the video. You can find clove and organic cocoa and curry and black pepper and so on. Save a bunch of cash by getting your spices in bulk. Don't buy tiny bottles. That's ridiculous. Today's featured product on the Hemp Lucid shop, also linked below this video and on the homepage, is the MCT suspension full spectrum CBD. This has a slower onset and a longer duration because of the fat solubility. MCT oil suspended full spectrum CBD is there for you, linked below the video and on the homepage. Today's featured product is one that I'm wearing. Yeah, I'm wearing it right now. Don't pole vault the caldera. Our finest days lie ahead. If you're going on a volcanic vacation, leave your vault pole at home. I've got the socks. I've got the shirt. It comes in various different products. The colorful design there featuring Steve Stimpak, the world's most famous volcanic pole vaulter. Don't be like Steve. Steve quit pole vaulting volcanoes for the kids. He didn't want to be a bad influence on the children, folks. So again, if you're going on a volcanic vacation, leave your vault pole at home. Don't pole vault the caldera. If you're going through hell, keep going. Our finest days lie ahead. It is a message of positivity and perhaps some humor. It also does feature our .com and our YouTube channel. It is our top seller, by the way. Lots of people have the product already. So have you gotten some Do Not Pole Vault the Caldera gear? You can find links to that on the homepage at smashomash.com, as well as below this video. And welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We've also got a paid subscription service where we send out additional content. We send out email alerts as well, even to bronze level. There's also a silver, there's a gold, and there's a gold annual paid up subscription level at smashomash.com/smashteam. So help us continue to create these videos. Keep them publicly visible and free for all to view. Help keep them existent by becoming a member at the Smash Team. A crack YouTube unit was sent to social media prison for a crime we did not commit. We promptly escaped a maximum security social media stockade to the internet underground, where we survive as producers of fortune. If you have a problem, and if no one else can help, and if you can find the content, maybe you can hire the Smash Team. No, you can definitely hire the Smash Team. That's why we created the site. If you can see this video, I'll bet you can go to a website, smashomash.com/smashteam. We'll close out with U.S. Doppler radar. It shows vertical motion in the air column from these ground-based Doppler radar systems. Alaska getting some heavy precip. We'll focus on the lower 48 to close this mother out. Here is clouds and fog over the lower 48. And it's clear over a large portion of the country, so a lot of people would have had the opportunity to see aurora. And here is the water vapor map. An upper level low here over Texas is full of dry air. However, it is still rotating counterclockwise, as you can see there. Here's your recap, U.S. Doppler radar. Clouds and fog as another CME. Actually, 2 more CMEs are headed toward Earth. And there is the water vapor map. Anyway, thanks for tuning in. Once again, congratulations on realizing the channel exists. Once again, thanks to our new subscribers. We'll see you soon. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back, whether or not you're in your bunker. I'm going back to the bunker. I'm going back to the bunker again. Whoa!